Greetings and welcome. Today, we will review the routine problems faced by the building maintenance managers along with their electricians and technicians. This presentation will provide insights into everyday challenges encountered by building maintenance managers and technicians and how to deal with the issues faced routinely. You have a busy routine if you are facing the following issues listed below: lights flickering, equipment resetting, or malfunctioning unexpectedly, clocks running fast or slow, motor speeds fluctuating, overheating of equipment, increased motor noise or vibration, unequal voltage across phases, motor overheating or inefficiency, increased electricity bills, overheating of wiring or equipment, interference in communication systems, distorted audio or video signals, visible flickering of lights, especially with the operation of heavy machinery or equipment, increased instances of equipment failures, premature aging of electrical components, frequent computer crashes, malfunctions in electronic devices. These symptoms are indicators for issues with the electrical supply, affecting the operation of equipment and systems within a building. What are the daily challenges that operation and maintenance people typically encounter? Are these happening in your building? Motor issues, HVAC system problems, pump or fan failures, control system malfunctions, lighting system issues, elevators and lifts problems, equipment tripping or shutdowns, increased maintenance needs, energy inefficiencies. These symptoms are indicators for issues with the electrical supply, affecting the operation of equipment and systems within a building. These are symptoms due to poor power quality. Yes, these symptoms and problems are due to poor power quality in the building electrical network. Let us illustrate the meaning of power quality. This slide highlights a distinct contrast between electrical sine waves. The graph at the top displays significant noise and distorted power, indicating poor power quality. In contrast, the bottom graph depicts a cleaner, well-defined waveform devoid of noise or distortion, serving as a clear representation of superior power quality. What do you notice happening in the building when power quality is poor in your electrical network? Here are some examples of the problems that the maintenance teams are experiencing: tripping breakers, automatic resets, data errors, circuit board failures, UPS alarms, software corruption, interruption of power, overheating of electrical distribution systems, motor failures, total power loss, electrical surges, spikes, hotspots, arc flashes, failures of lamps, ballasts, LED drivers, VFDs, inverters, rectifiers, transformer failures. Poor power quality can be mitigated with electrical maintenance interventions using monitoring equipment, conducting power quality assessments, and using power conditioning devices such as voltage regulators and stabilizers, surge protectors, SPDs, power factor correction, harmonic filters. These devices can help mitigate issues related to poor power quality. Unfortunately, these solutions are all static solutions that perform well for design conditions. They do not adjust very well to changing load conditions in our networks that are controlled by automation and computers. Option 2. The correct solution to deal with power quality and power management. To effectively mitigate maintenance issues within the building, the New World solution is Axon's comprehensive power management system and control device. This system adapts and adjusts seamlessly to fluctuating load conditions within the building, ensuring consistent, high-quality power supply to connected loads around the clock. Axon's power management system and controls device not only monitors power and offers data logging and remote data access, but also enables the printing of dashboards and reports. Additionally, it excels in effectively becoming an all-in-one solution. It does what several solutions were doing effectively in electrical networks with static loads. In the world where we have dynamic changing loads controlled by automation controls, Axon's system replaces or complements the following: voltage regulators and stabilizers, surge protectors, SPDs, power factor correction, and harmonic filters. Instead of using several technologies and devices, you now can use one power management system from Axons. It is important to note that this power management system uses the data it collects from the network and fixes the problems to mitigate all power issues in the electrical network. This is a major difference between other power management systems and the power management system from Axons. This slide provides the importance of power monitoring in buildings and electrical networks. Without the energy data, there is not much you can do to fix the problems. Existing power monitoring systems can only gather data, they don't fix any problems. Example: when there is lower power factor indicating the presence of dirty power in the network, power monitoring systems cannot fix this problem. You will have to seek out other equipment that mitigate the dirty power. In contrast to all other power monitoring systems, Axon's power management systems will not only identify the low power factor, but it will also improve it close to unity power factor by removing the dirty power from the network. Another important point to note is that Axon's power management and controls device is not a parasitic load. Axon's power management systems and controls device reduces watts per square feet, EUI, and carbon emissions. These attributes of reducing watts per square feet and EUI are very important for obtaining city, state, federal, and utility incentives for energy efficiency. This slide is a graphical illustration of the performance of the Axon's power management and controls device. The first half of the graph shows the performance data without the power management system. The second half shows the performance data with the Axon's power management system. The green color indicates the presence of dirty power in the electrical network. The dirty power is minimal after the Axon's control device is installed in the same network. This graph also shows the white area that represents the transformer capacity with and without the Axon's power management system. In short, Axon's power management releases capacity and the load on the transformers, resulting in decrease in current, demand, and consumption. Customers are using this power management system and controls device since 2011 in America. It is a requirement for the compliance with building standards benchmarking in addition to energy savings and saving operational and maintenance costs. Please contact your distributor or representative of Axon Inc. Thank you for listening to this presentation. Have a wonderful day.